Perfect. Well, thanks everyone. I know today is AGU abstract deadlines, and so I'm sure a few folks have that on their plate. I've got a few too many, but that's all right. Yeah, so who wants to start us off?
I can go first. So I did find a little bit of a window, Dieter, to do the EM1D stuff. It's not finished yet, but I've made some progress. And right now I'm going through the tests. So yeah, updating all of the tests for Travis that would work with the latest simulation stuff. So yeah, I'm pretty much working on that. Dieter noticed that he had some import errors that I didn't have. And I guess he believes that it has something to do with him working maybe on a Linux machine and me on Windows. So essentially the game plan is for me to go in and fix those tests and make a pull request. And then Travis might catch the import error or catch any of those errors. So some progress is being made. I'm doing this AGU abstract, but it's high on the list for me there, Dieter. So hopefully I can continue to chip away.
No worries. I'm on a holiday from the next 2 weeks, and I don't get much done before that. So it will be mid-August, the earliest I can have a look at it.
Okay.
But it's an interesting issue because it's import case sensitive, which is not case sensitive on Windows, but everywhere else.
Yeah, and I've tried to just make everything lowercase and everything match what we do in SimPEG because, yeah, I don't want to have that issue as well.
That's cool.
So we'll see what happens.
One thing it could be, this is also super annoying, is Git is not case sensitive on file names.
That's happened before, and I looked for a Git ignore if there was anything in there that was funky. Try clearing the Pi cache.
No, it's a feature of Git. So
Yay,
one of the super annoying things, and I did a bunch of this when doing the refactor of simulation, especially with details. What I ended up doing to get Git to recognize it is it's silly, but I basically renamed it to just something temporary.
Yeah.
And then rename it to the lowercase thing that you actually want. And so that will trigger that. But that actually could be an issue right now, that even if you see things as lowercase on your machine, and you've pushed changes, it might not actually be lowercase on Dieter's machine. So there could be a case sensitivity issue if you didn't actually ensure that. So check on GitHub if it's capital or lowercase on the branch that you're on.
Okay, so then, I mean, one thing I could do, I could actually just go on to GitHub and look at the files, and I might be able to rename them through GitHub if they're capitaled.
You might be able to, but you might actually have to rename it to something temporary. I don't know.
So something random. Okay, yeah.
Which is what you actually want.
But I guess what I mean is I would be able to go into GitHub and actually see which files were uppercase, so that I'm not just randomly changing all of the files. So I'd be able to kind of zero it in. Okay, that's really useful, Lindsay. Thanks.
But it probably makes sense that Git is not case sensitive if Windows isn't. Otherwise, you would have cross-platform issues.
Yeah.
I see. Yeah.
Potentially, but it is rather annoying for many other things. Yeah. Cool. Excellent. Thanks, Devin. Anything else? I know AGU abstracts are the big one. Cool. Well then, Dieter, do you have any updates you'd like to share?
Yeah, well, I had this new version that came out that has this simulation in it. And since then I was pretty much busy with updating the benchmarks and the examples for it, which took me much longer than I thought. They'd make me a lot of fight with environments, which is the same as for our 3D paper, which seems to be at the moment a bit of pain, but yeah. So Python environments. Other than that, probably the two things I wrote in the dev channel about the license, which might be an idea. and the warnings, but I think Joe is on that with the warnings. And also the discretize, there's this matplotlib. If you update the matplotlib to 333, you might get warnings with plot slice and the 3D slicer, because we're not, I guess it's something from before. We have the clim, but then you can also pass in vmin and vmax in the popt, how is it called? Yeah, in the optional arguments for the slicer and the other things. So we probably have to think about that maybe if we want to deprecate the clim altogether, to just have it in one place or not, or because matplotlib since a while, since a year or a bit more, they become more pushy to clean up and remove old stuff and be more streamlined. I guess it's a painful process, but down the road it's good for them. But so we have to, maybe particularly with discretize and their plotting functionalities, we have to keep up with that a little bit. And yeah, that's it. Maybe Lindsay, you have more an idea when you will have the block model?
Yeah, so I've been working on that. I was hoping to get you something by Monday, but of course that didn't happen. But it's getting closer. So I've been running simulations on Google Compute, which is actually really fun, getting up and running with that. So what I was actually hoping to do is get the layered model basically cleaned up either today or tomorrow, and then send that to, I'm glad Sagi just showed up. I was going to send it to Sagi and to Joe, and just if they have any other input or ideas. The thing that's really been interesting to sort of get a sense of is really how sensitive you are if we really want to drive down error to padding cells. Not just with respect to boundary conditions, but also if you pad too aggressively, it does reduce your accuracy. And so trying to find that sweet spot where we're basically, we're padding sufficiently to satisfy boundary conditions, but not so aggressively that we're degrading the accuracy of the solution, it's more fiddly than I thought it would be. And so I'm to the point of sort of 3% median error on the offset line. I know we can get it lower, because what I've seen is if I violate the boundary conditions a bit, the center of the solution gets below 1% error. But then of course I'm violating boundary conditions, so the tails of the line are bad. So yeah, so a bit of fiddling, but hopefully I think that in a week or so we should have that basically good enough. I mean, I might still be polishing it a bit, but something that we can sort of consider it worked in. The modeling model is probably going to be a few more weeks out at this point. So.
Yeah, I'm got quite delayed now as well, and Rafael wants to try. He wants to push out the version 1 and run it again, which he says a week or two. And then next 2 weeks I'm off, so yeah, we probably get a bit delayed there, but hopefully not too much.
Yeah. But my goal is to get it sent to other people to look at by today or tomorrow. So that's cool. I will ping you and let you know, so you can bug me.
Good. Good. Thanks.
Yeah.
Yeah, that's it.
Excellent. And thanks for bringing up those licensing things. I think that's a good discussion point, and we can maybe loop back in with Joe when he is.
It's on GitHub appeared that EMG3D is used by one project, which surprised me.
Yeah.
So I looked at it, and it's a Brazilian who mixed in EMG3D and SimPEG, and it's a funny repo. I think he's new to programming. There's a Pi cache in it, and all the other files, but they're in. But then often, and the things have that's no problem. I don't care. But what often then happens, then the files are in, but the license is not in. So as soon as that happens, you actually don't know. I mean, it can happen purposefully, and that we can't avoid. Someone can always rip it off. But I think in this case, it was accidentally, because you take a file, but that doesn't mean the license is there. So I think it would be good to, and with these identifiers, which are pushed by the Linux Foundation, this would be just one line or maybe 2 line with the website and then it's not a lot of code or not a lot of space that it would use up. And if somebody copies a file, it would retain the minimum information of where it comes from and what's the license.
Yeah.
So
yeah, and I think that's a really good idea, especially for projects like SimPEG and EMG3D, because like if you are sort of in a research project and you really want to play with the methodology, like sometimes copy and pasting the file is your starting point. And that's not an unreasonable thing to do, but we want the provenance and the licensing.
And like forking works if you're on GitHub, but even if you just want to work on GitLab, then you can't just do a straight fork. So yeah.
Okay.
Yep, that's me.
John, do you have anything you'd like to update us on?
Yeah, just been playing around with the MT still a bit. We have a project coming up where it's going to be a big, long 2D line. So I jumped back into that doing 2D and 3D kind of sense, and just started playing around with how many padding cells I'm going to need in the one direction, just to make it look like that. Yeah, I can extract something 2D that's reasonable. And yeah, it's looking really good. I can do at about 5 frequencies. I can do about 100 stations in 6 hours. So yeah, not too bad. And it converges, and yeah, it was looking pretty good. I didn't play with the X-ray stuff yet again. I was just kind of busy with that and the mump solver. So I got that all built, and it's been really nice being in Linux. I'm not going back. It's once I've gone back, it's hard to go back to Windows. But mumps is really interesting. I'm finding it's about an order of magnitude faster than Paradiso, just as is. If I think I did a 10,000 by 47,000 matrix, inverted it, and it took about 0.1 milliseconds with Paradiso and a 0.01 milliseconds with mumps. And I think that's because Joe was saying that the factorization is parallelized now too, or in mumps. So yeah, it really makes quick work of it, and it scales. Yeah, as I plotted a little bit of a plot there on the dev channel showing that yeah, as you add the cores, you're seeing scaling. And then I did it at a couple of size of matrices as well.
Yeah.
And as the matrix gets bigger, the more cores are helping out as well. So you get a little bit more. It actually, the curve, as I'm upping the matrices, it's almost getting more linear than kind of logarithmic. So that's kind of interesting. If you go from 1 to 2 cores, when you got a really big problem, you don't see much of a gain. But then as you add them, it just I guess once it breaks up the problem into the parallelization, then you can just start adding cores, and it actually benefits.
Yeah.
Whereas smaller problems won't need, yeah, I guess that many cores to actually get more speed. Yeah.
How did you build that? Did you build like mumps from source? And
yeah, so I went into the documentation, and actually a lot of it was through PETC. The documentation through there, they had a lot of recommendations on what to use to build mumps in a parallel fashion. So the main ones was one called Scalapack, and Blast, and OpenMPI or MPI. Those are the 4 main ones to get some really good speed. And then for like the parallelization itself, I used Scotch. Yeah, it's I can't really remember how they explained it, but it kind of like distributes the threading, and it kind of manages all that more. And you can also team that up with another package called Metis or Parametis. And I haven't got that one to build properly. So I think we can even get more gains if we can incorporate that library too. Yeah. But yeah, I built everything from source in the most optimal way to get scaling and parallelization. And seems to have worked. It's just now my problem is getting PyMumps to compile the C side of things. The Fortran compiler seems to be working okay, but when I try to do the C compiler, it's having problems finding the mumps headers. So yeah, I'm just fighting with that right now, and hopefully by the end of the week I can get it incorporated into. Yeah, I can run an inversion with it through SimPEG.
That would be excellent, and I would certainly appreciate maybe chatting through this with you at some point. For the Marlum model, I think we're going to need it. I was
hoping that I could maybe push that in there if I can get it.
that would be great. I mean, and either I can try running it on Google and like sort of try and replicate the build process, Or I can also, like, we
Yeah.
can just iterate and set it up on one of your machines if that's okay. And see if we can get both going. That would be kind of cool.
Yeah, that'll be the next thing that I'll be doing.
I,
Yeah, for sure. Oh,
that would be cool. And I mean, we can also update that in the paper in the review stage later if that will come. Also for the block model. I guess you have to be careful with language though. You can't say mumps is 10 times faster than Paradiso. It's 10 times faster than the Paradiso version we are using,
yeah.
which is 14 years old. There's a newer version, and then I don't know if it's faster than the new version of Paradiso. So I guess
The
not
new
that
Paradiso.
someone who watched the video gets the impression that Paradiso is really bad. It's just we're using an old version of Paradiso.
Yes, thank you for catching that. Keep us out of trouble.
Yeah.
Yeah, it's looking pretty promising, and I think we'll get some really good speed ups in our inversions if we can get mumps going. I've now that I've went through it, and when I look back, it's actually not that hard to build, but it was kind of a pain at first. So I think that whoever builds it next will probably have a better experience.
You remember when you were struggling with that, I guess.
Oh, it was kind of. I just kind of forgot all the little make and then the make files and how all that syntax works, and some silly mistakes that kind of held me up, but got it figured now.
Right. So on a Python side, what are you doing, John, to wrap it up?
I'm just trying to use Python to just compile some, I guess, just a wrapper. But that's what I'm having a problem with right now, is trying to get PyMumps to find, or when it calls the C compiler to find the headers. And it's, then I direct it at the header. I can put in the whole path and it'll find the header, but then it's having a problem with the object files. So I don't know. I might contact PyMumps and just ask them what they're, or whoever's, I think it's pretty kept up to date. So hopefully I can get a reply from them and get over it, or I'll figure it out by the end of the week, one of the two.
Or Joe.
Oh, sorry?
Expertise. Joe, that's fine. We have our local expertise. Not mumps, but I guess that's Python and C compiler.
Yeah.
Wow, great. I think initially we used the mumps, and I think at that point Lars compiled. I'm not sure. I think Lars at that point he was a postdoc in UBC. He compiled, and then Rowan wrapped it up with PyMat solver, and the installation was a headache, but it worked actually well at that point, and it was a serial mumps at that point.
Oh, the serial mumps, yeah.
Now we're updating with. It's great.
Yeah, it should be quite optimized now.
Yeah.
That's really exciting, John. I think that's going to be a big step for the whole ecosystem.
But is it free, John? Like that mumps version is free?
Yeah, even Scotch and those other packages, they're all freely downloadable, or they're all freely available. Yeah.
But let's say if you write up a wrapper in Python, and can you put some sort of an open license into it? If you build a package that wraps it up a mumps, and then if you write let's say PyPy package, for instance, can we just assign a MIT license, or I was just curious what we could do with that.
I haven't quite gone too far down that path yet. I'd have to figure out, or I'd have to look into that a little bit more in the details. But I can't remember I'm not sure if we can just apply an MIT license. I'd have to look in. I'll have to look into that a little bit more. Get back.
What is the license of mumps?
Oh, what was it? I was looking at it the other day. Let me see.
The other thing I was going to jump in and say too, it also depends on what you're distributing. Odds are we're not actually going to redistribute mumps in a package that we wrap, right? So if we're just writing code that imports mumps, that should be fine, and you should be able to license that piece that connects mumps to Python, however you choose to, as long as you're not basically repackaging and redistributing mumps.
That's, I think, pretty much what PyMums does. Like it says in their installation, it's like, oh, you have to have mums built already for us to use. Like we're not doing all that for you.
Yeah.
But I guess the Conda recipe builds the sequential mums. So I don't know how that exactly works. Maybe we would end up doing something like that. Why can't I find this right now? What's the license? Yeah, I'll post some stuff about it here on Slack once I get it here.
Right. And John, what was the problem of PyMums? It seems like there's a package.
Yeah, it's PyMums is just kind of like what you were saying. Like if we were to write just like a wrapper to use it, that's all that they do. They just have the wrapper for it. You have to have mums already pre-built. So what my problem is compiling PyMums, having it recognize where my mumps is and use those.
Oh, I see. I see. So your strategy now is basically compiling your own mums and then use PyMum package to be used in Python. Is that right?
Yeah, I was thinking of going that way first just to make it easy, because if the wrapper is already built and then looking at their syntax, it's pretty easy to use, pretty straightforward. But if it comes down to it, yeah, I'll start writing our own wrappers. And it might actually be useful because you have access in mums to a lot of good information, like how much time it's or RAM and time spent in any part of the solving, and yeah, it's actually really interesting. Lots of good things you can pull out.
Right.
But yeah, that's where it sits right now.
Thanks, John. That's really exciting. Sagi, do you have any updates?
Nothing really particular. Yeah, I wrote some AGU abstract. Yeah, submitting one for DC. I think the open source session, the tourable open source software or something like that. Seems like there are lots of abstracts already submitted.
Oh, that's great.
Yeah, I just looked around and I think the listing was actually quite diverse. I was from atmospheric sciences to crustals and some near surface physics. I thought that's pretty diverse. Yeah, other than that, I'm finalizing this geostatistics stuff. And I found a package called MPS library open source package. I'll share the link later. So yeah, it seems like people, I think it's a Danish people who's revamping like GS library or MPS library that has been developed for like a while ago. But I think it is written in C, but they're wrapping up in MATLAB and Python. So yeah, it's we could like readily use, I guess. I haven't tried, but yeah, it seems like there are open source that anybody could use it. So that's an interesting. Yeah, so living in an open source community is interesting. So you just need to search, and all of a sudden you find, oh, okay, there are packages. Other than that, I wrote an abstract also for AGU about the sparse inversion. Well, it's not necessarily the sparse inversion, but I used the mixed norm inversion to answer some hydrogeologic question, like imaging the thin clay bed. It's very extensive clay bed in the Central Valley. So yeah, people living in Central Valley know there are like a very extensive clay layer which act as an aquitard. So simply their groundwater model is 3-layer model. You have upper aquifer, clay, and lower aquifer. So actually imaging that clay layer very well is a very important task. So once you can image that very well, you can readily update their groundwater model as a first shot. So yeah, and then you can expect, what kind of impact that made to your groundwater model. So yeah, it's an interesting application. And I use the mixed norm approach that developed. So yeah, that'll be interesting to see. I think that's it on my end.
Thanks, Sagi. Thibaut.
Yeah, not much update on the SimPEG side. Like I worked a bit on merging my branch with with a new master branch with simulation, but with all the name change is a bit of a tedious process. So I'm doing one bit at the time when I feel for it, and otherwise, yeah, I've just been looking around like at like what people were doing with GeoSci or PyTorch or other things like that, just like trying to define the next problem for me. What's the next thing I want to solve?
Excellent. Doug, do you have any updates?
Well, we're thick in AGU at this point. I did have one for John, and that is, do you have a like sort of a standard test that you're using by which you're comparing mumps and Paradiso, and just how long it's taking for factoring and how long it how efficient it is with respect to solving multiple right-hand sides, or just a standard test that we can say, well, if we've got a slightly different version of one of these guys or something else is different, that we just have something to compare against.
Yeah, I don't right now, but that's kind of what I'm putting together right, kind of as we speak. I just wanted to get it built, and then we were going to start, doing some comparisons, pulling out the information, how much time it spends in, factorization. Nothing right now I've got set to do for comparison, but just like the stuff that I've been running right now is I've just been, doing a fields problem for a DC and running those through each solver. Paradiso, or I guess it's Paradiso MKL, I guess really is what SimPEG is using, and in the mumps Fortran in interface.
Okay, that sounds good.
But nothing right now. But I don't know if you got any idea, like if you got a problem set that might be interesting, a couple to throw through there. Once I get it built, we can set you up, or we can set up and try it for sure.
Have you tried anything from frequency domain that's a complex system yet?
Oh, actually, that was what I did yesterday. I forgot. I forgot. Yeah, I compiled the Z library, which is the double complex, and everything worked out pretty well. Same results. Actually, I didn't compare the accuracies yet, but they generally gave the same thing.
That's great. Yeah, because I tried playing around as a part of sort of working in this paper or working on the simulations with Dieter, playing around with trying to get even serial mumps and sort of PyMumps installed. So I went down like a little bit of a rabbit hole and decided to stop because I couldn't actually, I tried passing it a complex matrix and PyMumps was not a fan of that. And so I think it's actually something in the wrapper. I don't think it was with the build, but anyways, all of these fun things. So that's what flagged for me, making sure with these comparisons, it's worth, I think, always testing something that's real and something that's complex.
Yeah, that's the thing with like mumps. I would assume that like the pre-built package would install them all, but doing it manually, you literally have to tell it like I want these kind of like float or double complex, and I built both of those to test them, and they're both.
That's super cool. I guess maybe any other updates. So I've also been working on AGU abstracts. There's one that we're putting in on MT. If there's anyone else who wants to join in on that, if that's something you'd like to contribute to, please feel free to add your name. And please just ping me because I have already set up the submission, so I would just need to update it, but that's not a problem if you are interested in contributing to that. Or if you're, if you don't add yourself and later on you contribute, we'll absolutely add you to the presentation poster, things like that. So, so there's that. The other thing, so with that abstract, one of the things that I put in there is sort of these ideas around starting to monitor or have visualizations that you can monitor inversion progress or perhaps simulation progress. So the first thing, I just started playing around and getting a sense of Bokeh, the plotting library, because you can stream data to Bokeh and actually, like, you can set up a server that is sort of independent from your Jupyter server, because like matplotlib, right, you just get a static figure, whereas if we want to be monitoring something, we want that data we want the plot to update. as new data comes in. So I've started playing around with it a bit. The API is quite different than Matplotlib, so it definitely is just, right now, it's extremely time consuming because it's just like, how do I plot a line? And it took me a little while to figure that out. But their examples, thankfully, are really pretty good. The other thing I want to sort of get a better mental model of is there's bokeh, but then there's also hollow views. And so hollow views aims at being basically like a higher level, well, this is my understanding at this point in time. Basically, it aims to be an API for all of the plotting libraries. So you can set the backend to hollow views to Matplotlib, or you can set it to bokeh, or you can set it to Plotly. And so that's one that I would like to get much more familiar with, because I think that would be a really nice option down the road is, you can just choose whatever plotting library you like and set that. And so thinking through some of the plotting utilities and things like that we have in Discretize and probably in SimPEG, it would be nice if we can get to a point where we're perhaps using that. And then like if you're writing a paper, you want to be using Matplotlib, that's great. But if you want to, create something that's interactive and has more of these HTML, JavaScript style plots, then you can pick your favorite library. Yeah, so I'm sort of in the learning phase. So if anyone else is playing around with those and just curious, I'm happy to sort of iterate and ask questions of each other. Yeah, I think that's basically it from my end. Trying to think if there's anything else. Yeah, does anyone else have questions or thoughts or things you'd like to bring up?
Yeah, just remember that I stumbled upon this Sphinx Gallery MNE, which might be interesting down the road. So the MNE gallery also takes hours to build, and what they do is they just do some, they make a git diff and see what was changed, like in SimPEG, which files were changed, and then they decide from that which examples would be affected and only run those examples. Mm-hmm. So sounds good. I guess it would be quite a lot of work to implement, but maybe in the future. So in this way, we could run the examples as part of the CI. But yeah, here he is.
Oh, hey.
Hey guys.
Where are you?
Where are you, Joe?
I am. Let's see. 12th in McIntyre or 12th in McDonald.
Oh, you're almost home, Joe.
I don't have anything to do for 3 hours until the movers get here, though.
So you're just hanging out in your car?
Yep, I'm quarantining.
Well, just drive to Spanish Banks and then park and just look at the ocean.
Yeah. Such a nice day. I don't know how you guys are inside.
Because it has
we're
Wi-Fi.
protecting us. We've heard there's Americans coming up over the border, so we're frightened.